Hi, there is a question here we are supposed to integrate. How do we decide? How do we integrate? Actually, for we to be able to integrate this integral here, we are going to use integration by part. So first of all, I'm going to call this I. Let it be integral. So we have to decide u and dv, because from the formula is going to be u dv equals to uv minus integral of v du. And remember, the way we decide on u and v, we are going to decide it based on this series here. So if the function has inverse function, of course your u will be the inverse function. For in our case here, so u will be sine inverse of xc dx. I'm sorry, sine xc. And the u, dear students, will be the xc over square root of 1 minus x square. So that is the u. And what about dv? So dv will be x square dxc, dv will be the xc dxc, and we are going to integrate. V will be x square over 2. Now our integral u dv will be uv. We have written it already. Our integral is I, so I will be equal to uv. You have x square over 2 times v times u, which is sine inverse of xc, minus integral of v, which is x square du, so over 2 square root of 1 minus x square dx. So now our integral has become x square sine inverse of xc over 2 minus integral of x square dx over 2 square root of 1 minus x square. So now this integral here is just a normal integral. We are going to deal with it, and later on we are going to combine the answer with the other part. So this integral, let us go with it. Now having integral x square dx over 2 in the bracket square root of 1 minus x square, we are going to use sine inverse approach actually. So I'm going to say x is sine theta, and the x will be cos theta d theta. So this integral here, the integral now will be integral of x, it is sine square theta, the x, it is cosine theta d theta, over 2 square root of 1 minus sine square d theta. The result is going to be integral now of sine square d theta times cosine theta, of course, over 2 cosine theta, because 1 minus sine square theta is cos square theta, square root of it, so you get cosine theta. So cosine and cosine will be going. The integral will be actually integral of sine square theta d theta. So we're going to change sine square d theta into double angled formulas. We know that cosine 2 theta, it is 1 minus 2 sine square d theta. Okay, So we can say that sine squared theta, dear students, is 1 minus cosine 2 theta over 2. So now we are going to say that this integral here will be integral of 1 minus cosine 2 theta over 2 will be over 4 d theta. You have now integral of 1 minus cosine 2 theta over 4 d theta. It will be 1 over 4 theta minus sine 2 theta will be over 8 plus constant. But you know, what if theta? From here, we know that theta is sine inverse of x. So if theta is sine inverse of x, so you have 1 over 4 sine inverse of x minus minus sine 2 sine inverse of x again over 8 plus constant. Of course, this can be simplified further, but we can end up here. So we can conclude that actually integral of x cos inverse of x dx is going to be equal to x square sine inverse of x. So you have x square sine inverse of x over 2 plus now 1 over 4 sine inverse of x minus sine 2 sine inverse of x over 8 plus constant. That's all. I wish you all the best.